Okay, happy Friday. These notes are the second day of 9.3. So the first thing I want to do is just go over the general structure of a hyperbola. um, the vertices are on the two parabola-looking shapes. The foci are inside the parabola, just like they were in section 9.1. You know how like the Pac-Man eats the focus? Um, and then there's this box that's made up of the vertices and then these other 2 points, and then the asymptotes crisscross through the two boxes. Um, so a couple things to go through. If this is your center right here, the distance from the center to the vertex, either of those distances from the center to the vertex, is A. Hang on a second here. Okay. So A is going to go right there. And then technically this would be another A right here. The distance from the center to the focus, so from the center here to this focus, or from the center out to this focus, is C. And then the last distance we need to know about is from the center to the edge of the box. So from the center to the edge of the box, center to the edge of the box, that's B. And then now our formula is for the relationship between C and A and B. That's different than an ellipse. Remember, ellipse, that was a minus sign, now it's a plus sign. Okay, so now we're going to go and we're going to go backwards and write the formula. So again, I always start with a sketch. On this particular problem, they tell us where the vertices and the foci are at. So I know that I have a vertex at 0, 2, right there, and another vertex at 0, negative 2. And then I have foci at 0, 4, and 0, negative 4. So there's a foci down there, and there's a foci up here. So the parabola shapes are always eating the focus, so I know that it's opening up and down. Okay, so based on that, I know that my center is at 0, 0. And I can tell what A is because A goes from the center to the vertex. Center to the vertex is 2. And I know what C is because the center to the focus is 4. So now I need to figure out what B is, actually B squared. So my formula is C squared equals A squared plus B squared. So in this case, 16 equals 4 plus B squared. Subtract the 4, and B squared equals 12. And that's what I need in my formula. Now, since this is an up-down scenario, I have to pick the correct formula, and that is y minus k squared over a squared minus x minus h squared over b squared equals 1. Remember, with these formulas for hyperbolas, the a squared and the b squared stay in that order. They don't flip-flop like they did in ellipses. This is a minus sign instead of a plus sign. What does flip-flop are the x's and the y's. So now when the y's are first, it's up-down. So if I fill in my information, I'd have y minus 0 squared over 4, because that's what a squared is, minus x minus 0 squared over b squared, which we found right here is 12, equals 1. And if you just want to simplify that to y squared over 4 minus x squared over 12 equals 1, that would be great. Okay, next problem. Okay, draw a picture for this just so you get a feel for what's going on. Okay, I've got foci at -1, 2 and at 5, 2. And then I have vertices at 0, 2 and at 4, 2. So based on that configuration, I know that it's opening right and left. And then I also know that my center would be smack dab in the middle of those, so that would be at 2, 2. A goes from center to vertex, so from the center out to each vertex is only 2. C goes from center to focus, so from the center out into the focus, that is 3, right? 1, 2, 3, yep. So C is 3. And then now let's use our formula to get b squared. So c squared equals a squared plus b squared. So that would be 9 equals 4 plus b squared. So b squared is 5. This is opening left, right. So the formula that I need to use is x minus h squared over a squared minus y minus k squared over b squared equals 1. So now we're just going to fill in all the appropriate information. H is 2, k is also 2. So it would be x minus 2 quantity squared over 4, because that's what a squared is, minus y minus 2 squared over b squared, which we found right here, is 5, and then set that equal to 1, and you're done. Okay, last example. This time, hang on one second. Okay, so there's something a little weird going on. I had set a graph to appear right about here, and I'm not seeing it, and you might be now that you're watching this. So, hopefully this works out okay. Maybe I won't write in this area just in case the graph shows up. Okay, I'm going to go over here and I'm going to hand graph it. This would have been a lot better on an actual grid because with these lines that I need to graph, it's much easier on graph paper, but I'll do the best I can. Okay, here we go. We have a vertex at 1, 0 and at -1, 0. So right now I know that the center is smack dab in the middle of those, so the center is 0, 0. And I know that A is 1 because the distance from the center to the vertex is A, so that's 1. And okay, so now we're going to draw the two asymptotes in. And we have our two equations, and so from this we know that our slope is 5 and our y-intercept is 0. So that means it would go through the origin, and we, for a slope of 5, we would go up 1, 2, 3, 4, 5 and over 1. Or we could go down 1, 2, 3, 4, 5 and over 1. And maybe I will try to put a nice straight line. Let's see if I can get this to work. Hang on. Okay. That's about as close as I can get. Okay, now we're going to have another line right here with a negative slope, and it also goes through the origin. So maybe I'll do, no, I'll do blue. It's going to go down 5, 1, 2, 3, 4, 5 over 1. Or it could go up 5 this way 1. And let me get a nice line again. Okay. Okay, so you get the general idea that those are the two asymptotes. And we know that our parabolas would be opening left and right, so it would look something like this. Okay, but that's not the, well, yeah, that's kind of important. We need to know that it's left, right. But the main thing we need to figure out right now is what B is. And B goes from the center to the edge of the box. And the box is made up of, here, let me get a, okay, the box is going to be made up of the vertices and how far it goes out to the edge of the minor axis. Okay, now I'm sorry, I'm drawing on this pad where I can't actually see what I'm drawing. So can you kind of visualize that box and how the asymptotes go diagonally through it? I know this isn't the best picture, but the thing you need to know is that B goes from the center to the edge of the box. Well, how far that is that? 1, 2, 3, 4, 5. So our B value is 5. Oh, try that again. Okay, so we have what we need, and we know that it opens left and right. So the formula that we're going to use is x minus h squared over a squared minus y minus k squared over b squared equals 1. So let's put in our information. H is 0, a squared is 1, k is 0, and b squared is 25. And just to clean that up and make it go faster, it would be x squared over 1 minus y squared over 25 equals 1. And that would be our formula. And we knew that it was this formula, that the x stuff would go first because it was opening left, right. So again, this B was the important part. It's from the center to the edge of the box, and the box is made up of basically A and B. Here's A. Oh, that was my dog. A goes from center to vertex. B goes from center to the edge of the box, and those are the two dimensions that kind of form the box. Okay, so I'm running out of time. You have the rest of the period to work on the homework, and I will be back on Monday, so have a good weekend.